I am MD Abdullah Al Nasim, presenting our paper titled A Comparative Analysis on Bangla Handwritten Digit Recognition with Data Augmentation and Non-Augmentation Process. Our paper ID is 160. My co-authors are Refat Ifirdaus, Mahiman Jumhok Fanto, and Atikul Islam Chaudhuri. Let's move to the introduction section. In the area of computer vision, the handwritten character recognition problem is a classical one as it works on pattern matching. There is no computer which can beat the level of efficiency of a human brain. Artificial neural network is the evolution of those don't give desired output. But convolution neural network were the first recognized for their potential in the digit recognition task. There are sum and fold characters and sometimes they are combined. To reduce this problem, we developed a system which can detect handwritten digits from digit images. This is the figure of handwritten Bangla digit from a different user. Now I am going to describe our motivation for the work. Handwritten digit recognition has educational and advantageous importance. The motivation behind our research is to specify Bangla digit comparing to others. Bangla handwritten recognition can help to recognize any number plate, a number from text detection. So it is our first step in this research to separate all 10 numbers which are written in Bangla, and we also that how important augmentation is so to recognize Bangla digit recognition. We analyze many papers in the topic and some of them are given. Rapid feature extraction for Bangla handwritten digit recognition was proposed in a paper. In 2015, a Bangla handwritten character recognition system with the help of convolution neural network was proposed, which had 85.96% accuracy. A deep learning approach was applied to Bangla numeric digits using dataset CMTA DERB 3.1.1 and achieved 98.8% accuracy. Research on offline handwritten numerical recognition proposed, which was an ensemble of multi-layer perception. We use NumDB dataset, which consists of more than 85,000 images. There are 6 different sources of NumDB test dataset, and additionally, the test set A and test set C generates 2 augmented datasets. Among 7 testing set folders, 2 folders contain augmented images and the rest of the 5 folders contain non-augmented images. We brought all images to a fixed square size, which is 64 into 64 pixel, and augmented each image. The figure represented Bangla handwritten digit images from our dataset. The preprocessing process along with their operation name and given below. Additive Gaussian noise. It added any noise that might be instinct to the information. Gaussian blur. This is a linear filter applied to the image to smooth. Coarse dropout. We remove some black rectangular from the dataset using coarse dropout. Contrast normalization to control the contrast of the digit size or background. Rotation. We rotate an image from -45 degrees to +45 degrees. Salt pepper noise to sharpen the image by reducing sudden disturbance. Shear. Calculate pixel distance of a digit from left and displace it to the left or right randomly. Superimpose. In the dataset, we found some images where 2 digits in one image. We check only a weighted digit and replicate the effect of a weighted digit. Translation. If a digit is a side of the image, we remove the blank area of the image so that it comes in the center. It is called translation. We use two convolution neural networks with different depth and different image augmentation and compared their performance. DenseNet requires fewer parameters than an equivalent traditional convolution neural network. Each layer has direct access to the gradients from the loss function and the origin input image. We classify our datasets into two important terms. One, preprocessing of input image. Two, deep convolution neural network section. Here, this is the proposed model of our work, and in this model, each input image of size 64 into 64 pixel, we feed this input to our ConvNet, which had 64 5 into 5 filters 2 times, and then used max pull-up size 2 into 2. Then we use 128 3 into 3 filters 2 times, and then again max pull-up size 2 into 2, which is try 2. Again use 256 3 into 3 filters 2 times, followed by max pull layer of 2 into 2, which is try 2. Then we flattened the output that had shape 4096 and connected them with 64 dense neurons, and after that with 10 output layers. Data augmentation is a core process for improving the generalizing ability of any system. Data augmentation techniques that we have used for our system: Gaussian blur, additive Gaussian noise, affine transformation, coarse dropout, contrast normalization, FAFR, which we described in the data preprocessing part. In augmented dataset, we achieve 99.46% of classification accuracy, and for non-augmented datasets, we achieve 96.72% accuracy. This is the confusion matrix result for our non-augmented process. This is the confusion matrix result for our augmented process. We can see that the augmented process works better. Here, the conclusion part of our work. We reach the computer to the human brain by the important use of isolated digit recognition for different applications. The recognition starts with the acquiring the image to be preprocessed through some steps. Classification and recognition have to be done for a numerical text, so neural network seems to be better than other techniques used for recognition. In the future work on Bangla OCR based on this research, to analyze with different models and make a better one. Add more classes for numeric digits and compound letters. These are the references for this paper. Thanks for your valuable time.